Welcome back to science class. My name is Miss Rillieux, and this week we will be learning about the rock cycle. If you joined me last week, we discussed the three types of galaxies. So before we discuss this week's topic, the rock cycle, let's review what we did last week. So our warm-up activity for this week is a graphic organizer on the three main galaxies that we discussed last week. The first column represents spiral galaxies. The second column represents elliptical galaxies, and the third column represents irregular galaxies. So again, that is spiral, elliptical in the middle, and irregular as our last column. So we're going to fill in the information about each galaxy. So starting with the size and composition. So are they small? Are they big? What should we put for a galaxy? Absolutely. Galaxies are huge. They are enormous. But what about composition? And composition means what it is made up of. So what are galaxies made up of? Right. Last week, we discussed that galaxies are made up of billions of stars. So no matter if we're talking about a spiral galaxy, an elliptical galaxy, or an irregular galaxy, all of them are huge and made up of billions of stars. So for each one, I'm going to move the card that says huge and contains stars, gas, and dust. And that is going to work for all three. So now that we have identified correctly the size and composition of each galaxy, what about the shape? And we can tell from the three pictures that they have different shapes. Although they're all huge and they all are composed of billions of stars, they do look different. So let's start with our spiral galaxy. Can anyone tell me, what do we see or what can you describe about a spiral galaxy? Yes, a spiral galaxy has little arms kind of coming out of it. And so what we like to call that shape is a pinwheel shape. But what about an elliptical galaxy? What could we describe an elliptical galaxy shape as? Yes, an elliptical galaxy has an oval or round shape. Now here's a tough one. What about this irregular galaxy? What shape does it have? Absolutely. An irregular galaxy has no shape. That's why it's called an irregular galaxy. So let's move on to gas and dust. How much gas and dust does each galaxy actually have? Now, remember, shape is determined by the amount of gas and dust that a galaxy has. For example, if we start in the middle with our elliptical galaxy, it has a very defined shape. We can see that it is oval or round. So because our elliptical galaxy has such a defined shape, what about the amount of gas and dust does it have? Right. The reason that the elliptical galaxy is able to maintain such a strong shape is because it doesn't have a lot of gas and dust. So we're going to put little cool gas and dust. Now, if an elliptical galaxy is able to maintain its shape because it does not contain a lot of gas and dust, and an irregular galaxy does not have a shape, what could we say about the amount of gas and dust in an irregular galaxy? Right. Irregular galaxies, because they have no shape, they usually also contain they usually are made up of rich gas and dust. And the reason we say usually is because their shapes, they change. And one irregular galaxy doesn't necessarily look like another irregular galaxy. But for the most part, they all contain or usually are made up of rich gas and dust. Now, our spiral galaxy, where we live in the Milky Way, is also made up of rich gas and dust. And the reason we don't see usually here is because spirals always have the same shape. On the other hand, irregular galaxies, their shape varies depending on the irregular galaxy you're looking at. So that's why we say usually, because it can change depending on the type of galaxy, irregular galaxy you're looking at. So we have accurately determined the size and composition of our three galaxies. We've determined the shape of our three galaxies, along with the amount of gas and dust. So last but not least, what type of stars are in each of our galaxies? And again, let's start with the elliptical one, because again, the shape is also defined by the types of stars that each galaxy contains, because stars themselves are made up of gas and dust. So if you are in an elliptical galaxy, what type of stars do you think make up you? Or what type of stars make up an elliptical galaxy? Yes, an elliptical galaxy is made up of old stars. So when stars begin to die within their life cycle, they release a lot of gas and dust, and they contain less of it. And because they contain less gas and dust, they're able to combine, make this defined shape of what we call an elliptical galaxy. Now, let's look at our spiral and our irregular. They both are rich in gas and dust. And anytime a galaxy is composed of rich gas and dust, do we expect to see old stars there, young stars, or a combination of both? Right. We would expect to see a combination of both. In our galaxy, the Milky Way, the sun is a relatively young star, and that's why it's located on the edge of one of the Milky Way's arms. But as the sun ages and gets a little bit older, we'll see that our sun moved to the center of our Milky Way galaxy. And in the center of our Milky Way galaxy is where all of the old stars are. So our sun eventually will not be located on the arm of the Milky Way. It will, once it gets older, will be located closer to the center. So the young stars in the Milky Way are on the arm, and the old stars are in the middle. Now, irregular shaped galaxies, because they do not have a shape, and they kind of just have are made up of stars from different other galaxies, kind of when galaxies clash. That's how an irregular galaxy is made up of. So irregular galaxies, they are composed of both young and old stars, because whenever you make an irregular galaxy, it comes from different galaxies clashing, and those galaxies that clash contain sometimes old stars, sometimes young, sometimes both, and irregular gets whatever is left over in the crash of the galaxy. So irregular galaxies also contain young and old stars. So before we begin our session on the rock cycle, let's just review what we just did. Our first column represents our spiral galaxies. They have a pinwheel shape. Of course, because they are a galaxy, they are huge. They're made up of stars, gas, and dust, billions of stars. They're rich in gas and dust, which means that they are composed of young stars and old. In our second column, we have an example of an elliptical galaxy. Like a spiral galaxy, it is also huge and made up of billions of stars and gas and dust. But it has a defined shape. It is oval or round. And because it has this defined shape, we know that it is mostly made up of old stars with little gas and dust. And then last but not least, an irregular galaxy. Like a spiral and like a elliptical, It is huge. And again, made up of billions of stars. But it doesn't have a shape. And although it doesn't have a shape, it is also made up of rich gas and dust. It just depends on the irregular galaxy that you're looking at. And it also contains old and young stars. So now that we have reviewed our galaxies from last week, let's jump into today's presentation. So the focus for today is TEK 6.10b. Students will be able to classify rocks as metamorphic, igneous, or sedimentary by the process of their formation. Our essential question for today's session: how do rocks change from one type to another? So our agenda. First thing we're going to do is create a foldable of the three types of rocks. And then we will together complete an assignment called Which Rock? And then for our independent practice, we'll practice some multiple choice questions using a quiz is. And then last but not least, we'll practice a STAR practice question because the STAR test is just around the corner in May. The materials you will need for this session include just paper and pencil. And the first thing we're going to do is create our foldable. So you are going to fold your paper hot dog style, so long ways. And then once you fold your paper hot dog style long ways, you want to grab a marker and divide it into three sections. And to divide it into three sections, you just need to draw two lines. So a line here, a line here. And it doesn't have to be perfect. You can, just kind of estimate where you want, how to get your three sections. So once you have your three sections, you want to label the top one igneous rock, the middle one sedimentary, and the last one metamorphic. All right. So I'm going to say that one more time: igneous, sedimentary, and then metamorphic. And then we are going to open up our foldable, and we are going to take a pair of scissors and just cut two lines. So we're going to cut here and cut here. Just do not cut this back portion. That's where we're going to write. So I'm going to give about 20 seconds for you to create your foldable. For those of you who are just joining us, welcome. We are going to talk about the rock cycle today. Currently, we are creating our foldables. We are folding our paper in half, hot dog style. We are dividing our paper into three sections, one side, and we're labeling it igneous, sedimentary, and metamorphic. So now that we have our foldables made, let's jump right into today's lesson. So this is a picture of the rock cycle, and we're going to take it part by part, so don't worry. But I first want to show you what it looks like all together. So here you go. So now that we know what it looks like all together, let's dive into one rock at a time, and then we'll understand how all this works. So the three types of rocks we're going to discuss in today's session include igneous, metamorphic, and sedimentary. We're going to start with our igneous rocks. So igneous rocks are formed through cooling of lava or magma. They may or may not have crystals. And I have two pictures. So here is lava, hot lava, and once it cools, it'll form an igneous rock. And so if we go back to that original diagram, our igneous rock is here. And as you can see, we have magma here. And so whenever we cool our magma, it will turn into igneous rock. But if we melt our igneous rock, then it'll turn back into magma. And that cycle will continue. There are other things that can happen, which we will discuss. But again, our magma is here. Once it cools, it'll transform into igneous rock. If our igneous rock is melted, it will transform back into magma. So the second rock type we're going to talk about today is a metamorphic. And I love saying that word. But basically, that just means it's going to change in form. And the way that rocks usually change is from heat and pressure. So whenever we apply heat and pressure to one of the rocks within our rock cycle, they are going to then be called metamorphic rock. And we'll see that on our diagram on the next slide. So here we are. Here is metamorphic rock. And so again, if we go back to this igneous rock, again, we started with magma. We cooled our magma. It changed into igneous rock. Now, instead of melting the igneous rock, if we decide to apply heat and pressure to the igneous rock, it will then turn into metamorphic rock. So whenever we add heat and pressure to rock, it will change into metamorphic rock. And so our last, and I'm just going to kind of move my face a little bit. And so our last rock that we're going to discuss today is sedimentary rock. So sediments, they're deposited together, and once they are cemented, they form sedimentary rock. And so the key here is they have to be cemented. They kind of have to be glued together. That's what cemented means in a very basic form. And so once we do cement our sediments, then we are able to create sedimentary rock. So sediments can be anything that can be broken down, transported, and deposited. I'm going to move my face one more time. All right. So here we are. We're at our sedimentary rock. And as you can see, we start off with sediments. And there are multiple ways for us to get sediments. And sediments are just little pieces of rock. So if we start with our igneous rock and we apply, or it undergoes weathering or erosion. And weathering just means we break it down into small pieces. Erosion just means we carry it. But if we break that rock down into small pieces and we carry it, it'll then be called a sediment. And so once we have a sediment, if we're able to compact and cement multiple or several pieces or like hundreds of pieces of sediments together, then it will then be called sedimentary rock. Also, you can do this with metamorphic rock. So if we have metamorphic rock, and then we again apply weathering, break it down, erosion, carry it, it will form sediments. And as long as we are able to cement and we are able to compact our sediments together, we will get sedimentary rock. Now, notice that once it becomes sedimentary rock, it can also be broken down, weathered, and carried erosion and form sediment. So sedimentary rock can form sediments, metamorphic rock can form sediments, and igneous rock can form sediments. But the key to get sedimentary rock, that's a lot of sediments, I understand, is to compact and cement it. So this is the rock cycle. We have discussed igneous rock, which is formed from magma cooling. We had discussed metamorphic rock, which is formed whenever we apply heat and pressure. If we apply heat and pressure to igneous rock, it forms metamorphic rock. If we apply heat and pressure to sedimentary rock, it creates metamorphic rock. And then the last rock we discussed was sedimentary rock. So whenever we weather an erosion, any type of rock, and then are able to cement and compact those pieces together, it will form sedimentary rock. So metamorphic, weathered and eroded will form sediments. It will then be compacted and cemented to form sedimentary rock. And same thing with igneous rock. We weather and erode it. It forms sediments. And then once it's compacted and cemented together, it's called sedimentary rock. So now that we know the three types of rocks, igneous, metamorphic, and sedimentary, we also know how they're formed. Let's see and apply our knowledge to our next activity. So for the next activity, I'm going to ask a question and we're going to place the correct answer in the box. So if we compact and we sediment and compact a rock, what type of rock will be formed? Will we form igneous rock, sedimentary? Is that the rock cycle, or will we form metamorphic rock? Right. Anytime we cement and compact rock, we will form sedimentary rock. Let's look at the next one. Heat and pressure transforms rock into. So if we apply heat and pressure, what will we get? Right. Once we apply heat and pressure, our rock will change. And if our rock is changing, we know it will now be called metamorphic rock. Think about a superhero morphing into, or a human or a regular person morphing into their superhero. So, like Superman, him morphing into becoming actual Superman. So, anytime you see the word morph, it means to change. And so, you know that when we are trying to transform or change rock, it's going to be called metamorphic. And what about this one? If we melt and cool magma, what type of rock will be formed? Right. Once we cool magma, we're going to be able to form igneous rock. Which rock formation is the image representing? So, what do we see here? Right, we see little pieces. So, if we see little pieces, what type of rock could be formed? Absolutely. It's going to be sedimentary rock. Those little pieces are there after we have weathered and eroded our rock. So we'll form sedimentary rock. Now, what about this one? Which rock formation is the image representing? Right. If we're talking about underneath the earth has a lot of heat and a lot of pressure. So, if we're applying heat and pressure to rock, we're going to be able to change it and morph it. So, we know we're discussing metamorphic rock. And last one, which rock formation is this image representing? What do you see? Absolutely. I see lava. You see lava. And if we see lava, then what type of rock are we going to be able to form? Correct. We will be able to form igneous rock. Perfect. Great job. So let's see if you can do it on your own now. This rock was formed by lots of fossils that settled on the top of each other over time. What type of rock is this? Any ideas? Right, this would be sedimentary rock. There's no lava, there's no heat and pressure, so it would be sedimentary rock. Which type of rock results from melting and cooling of magma? Yes, that is igneous rock. This rock cooled on the outside of a volcano and contained air bubbles when it was forming. What type of rock is this? Yes, if we are talking about a volcano, we're most likely talking about magma. Therefore, we know we're talking about igneous rock. This rock started as molten magma. What type of rock is this? Right. Just like the last one, if we're talking about volcanoes, we're talking about magma, we know we're talking about igneous rock. What are the three major types of rocks? What did we learn today? Yes, today we learned about igneous rock, metamorphic, and sedimentary. Great job. So let's get into the last part of our session today, which is our exit ticket. And so, question number 1, sedimentary rock contains A, broken up houses, B, broken up cars, C, broken up rocks cemented together, or D, broken up people. Any ideas? Right. Sedimentary rock is made up of sediments, broken pieces of rock after it has been weathered and eroded. And once the rock is weathered and eroded, if it is cemented together, then it will form some sedimentary rock. So the answer to this question is C. Right there. It's not made up of broken cars, not made up of broken houses. But maybe if the house was had, I guess, like made up of brick, maybe if we cemented that together, then possibly. But definitely not made up of broken people. All right, so let's go to our last question. So, metamorphic rock can be made from. Right. When we see the word metamorphic, we have to pull out the word morph. And remember, that means to change. And so once we apply heat and pressure to any type of rock, we can change it. So the answer to this question is C. Any rock can be changed to metamorphic rock once we add heat and pressure. So before we end today's session, we're going to just do a quick review. Let me pull that up. And I'll just go back on the three rocks that make up the rock cycle. And so again, we have, if we're on this graphic, and I'll get my pointer, we have magma here. Once our magma cools, it will form igneous rock. Now, if this igneous rock undergoes heat and pressure, it will form metamorphic rock. But if this igneous rock undergoes weathering and erosion, it will form sediments. And if those sediments are compacted and cemented together, it will form sedimentary rock. Now, if our sedimentary rock is weathered and erosion, it will again form sediments. And then if it's compacted and cemented, it will form sedimentary rock again. Now, if we do not weather and erode our sedimentary rock, but instead we apply heat and pressure to it, just like igneous rock, it will form metamorphic rock. So that is everything that I have for you today. Thank you so much for joining me. I hope you have an awesome week, and I will see you next week. Bye bye.